All right, let's get into the demo. So over here on the left panel, I'm running this startup script that starts two nodes for Fangorn, a UI on localhost 3000, and also starts the substrate contracts node and deploys the Iris contract. Here in the middle, I'm running Fangorn or Entmood. This is just a nice little convenience TUI to interact with the network. It lets you generate and inspect keys to get started. So I've already generated my keys, so we can inspect. I see my public key. Right now, it just outputs a mnemonic to a text file, so not incredibly secure, but it allows you to easily import that to Polka.js. So here I've imported my wallet, my keys already, and I've already sent myself some balance. We can also see that the Iris contract is here, and that is empty. And here the UI just reads from the contract, and it's also empty. So to get started, I'm going to encrypt a text file. So here I have a text file. What time is it? 12:21 now. So 12:21 p.m. I'm going to encrypt this under a password. So here I will select test.txt and I'll select password from the list of intents. Each intent is a unique type of gadget and they're all composable. So we'll start with just password and I'm going to do test.txt with a test password, sorry. So then here we can go back to the visualizer, read all, and we see, okay, we have a new entry here in the list. We can read intent, and this will decode it. We see it's a password type, and this is the hash of the password, so we need to prove we know the preimage of this value, basically. So to do that, we're going to go and decrypt. Now, we expect this, when we decrypt this file, it should be output to plain text. So we just select password again, press space to choose the type, enter. We just put the file name, test.txt. So this will read from that contract. And then we put the password, so this is just test, click enter, and we see indeed we did get our test file output to plain text. Here each node, or threshold nodes at least, we have two, so each node will produce a partial decryption as long as it can verify the witness. In this case, the verification of the witness is like, did the password you input match the, did the hash of the password match the hash of the intent? If so, then you're good. So now we're going to go and do something a little more complicated. This will be a PDF. So my PDF is tickets to PandaFest last week. So I want to do this as a token-gated content. So to do that, I need to combine or compose two different intents, the PSP22 and the SR25519. So, but in conjunction, these let you prove that you own one of the PSP22 tokens. So here I'll click enter, and we need a contract address for this. So to do that, I will use this tool and deploy a PSP22 contract. You could also do this from Polka.js or this command line. It doesn't really matter. This is just for convenience. And here I'm going to import that contract so we can visualize it. Let me call it PSP22-PDF. And here we see it. And we should have that the Fangorn, this wallet has all the tokens, and we just default to 100 for now in the UI. So now what I'm going to do, I'm going to put the contract address. I need to put how many tokens it should use as the minimum balance. So you need at least one token in this PSP22 to access it. And we click enter, and once we navigate back to the UI and click read all, we see a new entry, test.pdf. We decode the intent, and we see it's a compound intent where you have the PSP22 and the SR25519. So now let's go ahead and decrypt this. And again, we expect this to be output into this plain text directory over here. Decrypt, again, I'm going to select both PSP22 and SR25519 by pressing space. Then click enter. Now we just put in the file name. Behind the scenes, this is going to prepare the signature based on whatever key we have loaded in the local key store. So since we own that contract, the signature should allow us to access it through those. And there we go. We decrypted and test.pdf. There we go. We got our PDF. We can also demonstrate what happens when decryption fails. Easiest way to do this is with the password version. Right now, the client is just going to crash. We haven't handled the error that well. So here, I'm just going to select password, test.txt, and let me put in a bad password. I'm just going to mash the keyboard, and that client crashed. And we see that each node, the nodes failed to verify the password and could not produce a partial decryption as expected. All right, thank you.